Can you all hear me? Cool, brilliant. Well, thank you for all being here this morning. A bit later than 9 a.m. And yeah, so today I'm going to be talking about PHP's type system and type systems in general. So a bit about me. I did a BSc in pure mathematics at Imperial College London. I've been working on PHP since 2019, and I've been funded by the PHP Foundation since 2022, which is the year it was established. So the PHP Foundation exists as a way to support and fund people to work on the language, to do maintenance, to do language changes, new features, bug fixes, security releases. And I think it's the main way I usually try to sell it is that like the PHP Foundation is your insurance policy for your companies, that in case there's a security bug in PHP itself, that it gets fixed in a timely manner. Because if there's a security bug in like one of your Drupal modules, okay, you need to update this and update every single Drupal website that uses this module. If there's a security problem in Drupal itself, well, then you need to update every single Drupal website. If there's a security bug in Symfony, then you need to like upgrade everything that relies on Symfony, Drupal included. And if there's a bug in PHP, then you need to update every single thing which runs on PHP. I mean, we've seen that a few days ago, like one of these weird websites got hacked. Not because of PHP, but you know, it tells you that maintenance is the hard thing to do, and it's not the glamorous thing to do either. Other small things, well, you can find me on Mastodon or on LinkedIn. You can find me, like my website. I will have the slides uploaded at one point, hopefully not too late, on my website. And yeah, I care about type systems and PHP semantics. So yeah, PHP's type system, so that's the first section. So what is a type system, really? So a type system is a logical system which has a bunch of rules where every term has a type. And a term like this type tells you what you can do, what operations you can do with your term. Now, in PHP, it would be every variable, every value has a type, and this type tells you what you can do. If you have an integer, I can do arithmetic. I can do addition. I can do multiplication. If I have a string, I can do concatenation, and these sort of things. Now, why do we care about types? If you've seen yesterday's talk about primitive obsessions, types allow you to abstract away, but give you more meaning, like give you semantic meaning about what your type can do. If you have a postal address, you can use this address to send a parcel to this. And you know that if you have a valid postal address, then you don't need to do the validation every single time. So PHP's type system has a few different things. So atomic types, which are like a single type, which have a few different things like the primitive types, user-defined types, singleton types, the very weird callable type that we have in PHP. And then we have composite types, and then we have a type alias. So atomic types, like the primitives in PHP, we have like the universal type, which means that every single value is part of this type, which is mixed. The resource type, which is what you get from like a stream, like if you do fopen, this doesn't have a type declaration in PHP. The primary reason for this is so that it allows us at different points in time to migrate a resource to an object. If you've used the curl extension recently, you will know that from PHP 8 or PHP 8.1, it stops using resources, but then now you have like a proper object that you can type and know that, oh, you will have a curl handler. The object type that exists in 7.2, which tells you, oh, anything, just give me any object. Arrays, which in PHP, they're not really arrays, what computer scientists would call. They're like hash tables and a bunch of different things. Then we have like 4 scalar types in PHP, so the booleans, integers, floats, and strings. We have what we call the unit type, which is null since 8.0 that it exists. Why we call it the unit type is because it's inhabited by only one element, null itself. And the asterisk is because you can use it as part of union types that we'll see a bit later, but only standalone since 8.2. And then we have like this weird, fancy empty type, which is never, that can only be used as a return type, which tells you that the function never returns. So it always throws an exception, or it calls the exit function, or it is an infinite loop and doesn't return. And then we have void in PHP, which is this return type, which is a bit of a lie, because any function in PHP actually returns a value. So even if you have a function which is a return type of void, and you evaluate the value, you will get null, because every function in PHP by default returns null. So user-defined classes, so that's probably what you use on a day-to-day basis, which we sometimes call class types. So we have classes, also known in type theory parlance like product types, because you can have multiple values that you have at the same time grouped together. Interfaces, and then we have enumerations since 8.1, which we call sum types or co-product, because they're the dual of product types, in that you can only have one single instance of that type. Then PHP has relative class types. Probably you very much use self and static, but you can actually use parent if you want. You can have a return type of parent and force sig. I don't know why you would do this. That seems extremely strange, but it exists. So yeah, singleton types. So singleton type is a concrete subtype of a type. So in PHP, we have false and true. So false since 8.0, that was introduced with union types, and true since 8.2. The main reason they exist is that, as you may know, a lot of functions in PHP, when they indicate a failure mode, they return false. You might get a string or false. You might get an integer or false. And saying that you actually return a Boolean when you can never return true, well, would be a lie and is less helpful. Similarly, true exists, and we added this in PHP because with 8.0, we did a lot of warning to error promotions, or there's been a lot of warnings to type errors which have happened. And so many functions which used to return either true or false, where false would tell you, well, you had a warning or an error, now always throw an exception, and so the only value it actually ever returns is true. And then you have some weird functions that return either null on success or false on failure. If you can find it, let me know. But yeah, sadly, you can't really define these in userland. You can't have an integer or a string. Oh boy, the callable type. The callable type just tells you I can call a function. It's it represents a function. And the way to get this is it's either a closure, which have existed for ages now, which is an anonymous function. You can obtain it via the new syntax in 8.1, which is my function, the brackets and then 3 dots. The 3 dots are part of the syntax. They're not fill in the blank. They are part of the syntax. And before 8.1, you could get it with either reflection function or reflection method get closure. It's either the string, which has the name of the function, like my function or strlen or whatever. An object method name pair, where the first element of your array is the instance of the object, and the second one is a string on which is a method name. And then finally, an instance of an object, which actually implements the invoke magic methods. You can't actually define a class property as callable. This is due to scope issues, in that some scopes where your variable will be callable will not be callable in other scopes. If you actually want a class property which has a function, just use closure, because closures are well-defined and encompass the scope within them. So composite types. Composite types are a way to combining multiple atomic types together. I think a lot of people will know about union types, which are available since 8.0, and since 7.1, we have nullable union types with the question mark in front of it. Intersections type since 8.1, which is I want a value which implements the interface X and Y. And then we have DNF types, which are disjunctive normal form, which is just a fancy way of saying I have a bunch of intersections within unions. So this is a way to visualize about maybe how the type system universe is. You have the big block mixed, where all the types live. You have null, which is its single element. You have your different sizes, where you have many arrays. You have many ints, but it's smaller. And then in objects, you have countable and countable and traversable and traversable. And the way I put it here is so that if you have an interface which says like, oh, I just want countable, then you can use any element in the countable like space, or like object. And traversable is like, well, I can use a for each, and I can like, they all live in there. But like array, you can actually use a for each on an array, and you can use count on an array. So if you want to just be able to do count on something, well, you can use the union type of countable an array. If you just want to use a for each on a value, well, you can use traversable union array. But if you want to be able to count and use for each on a value, well, you can say, well, I want something to be countable and traversable, or to be an array. Or if I just want to be some arithmetic, well, I want either an integer or a float. So why do we care? Is that an intersection type, like I tried to demonstrate, is that it allows you using every single API provided by each type. However, if you have the union, you are only allowed using the common API. So if you have something which is countable and an array, well, you can only use count. So type aliases, so since 8.2, iterable is a compile time alias, which is basically traversable or array. This has existed for a long time, I think since 7.0. It has always had these semantics, but prior to this, it was its own pseudo type. And yeah, you can't define a type alias in PHP. And I don't know when this might be possible. Some C code. Hope I don't scare you. So internally in the engine, every value is what we call the Z-val. And it's basically associated of the actual value and a type information. And the type information tells you which type it is, and for the optimization, we also split false and true part of it. And this allows like for somewhat fast type checking for primitives. And otherwise, for representing type declarations that they use in property types, return types, parameter types, we have the Zen type structure, which has a bit mask of primitive values. Or you have a pointer, which is a class name. And for more complicated types, a list of types, which just tells you how many types you have, and then like every type individually. OK. I hope this wasn't too bad. So let's go on to like subtyping and LSP. So what is subtyping? So in PL series, subtyping is a form of type polymorphism, where you can use a subtype at any point that is related to like another type by some notion of substitutability, which basically means that like any time if S is a subtype of T, anywhere I can use T, I should be able to use S as well, safely. And that like nothing weird is going to happen, nothing is going to break, or anything like this. You will see 3 different syntaxes, because mathematicians and computer science clearly can't get on with each other with naming or stuff like this. So yeah, you might see one of these 3 different ways to go along. We will be using the square equal subset notation in this talk. So LSP, so the list-scope substitution principle, is a particular definition of a subtyping relationship. You have many others that exist, which is called strong behavioral subtyping. And it was formulated in 1994 by Barbara Liskov and Janet Wing. And formally, it tells you, OK, let phi of x be a property provable about objects x of type T, then phi of y should be true for objects y of type S, where S is a subtype of T. OK, it's a bit complicated. But basically, this is how you can visualize this. Is that like you want to be able to replace one component within your whole data pipeline. If you want to interchange like one of the elements, you need to be able to accept everything that comes in before, but you can accept more, and you need to like only output everything that was expected before. But you can be more specific, which is why you have like the weird funnel. Like it's like, well, you can accept more, and then you can be more specific. Roughly what it means, and like roughly what it is like, so preconditions, you cannot strengthen them in the subtype. Postconditions, you cannot weaken them in the subtype. The invariants must be preserved. And then there's this thing which is called the history rule, which is the constraints must be preserved in the subtype. We'll go back to the history rule in a bit. But what LSP does on signatures, which is what PHP will check at compile time when you do inheritance or interface implementations, is that a method cannot add mandatory parameters. The parameter types of a method must be contravariant, i.e. a supertype, and the return type of method must be covariant, i.e. a subtype. And property types, we say they must be co and contravariant, because you can write and read from them. Just the reason like why it's called co and contra. Co means that we follow the same direction as like our relationship. So we want the signature to be of our subclass to be a subtype of the function signature of the parent. So the return type is covariant because it follows the same relation. It is a subtype as well. And contravariant is because the parameter types like go the opposite way. Now, small expansion on the history rule. So what it kind of means is that subtypes must not alter the state of the supertypes in ways that are not possible for the supertype to do. So if your supertype has a method that only ever returns even numbers, you cannot have a subtype that starts returning odd numbers, basically. But also, if you have a list that is constrained, that it has only ever 4 elements, you can also not have more state in it. You can't have 5 elements or 6 elements. And the problem is, like, this cannot be checked by a compiler. This is something that you, as developers, need to be aware of and need to take care of. And this is also the reason why generally we say composition over inheritance, and why we say, and other people say, protected methods and protected properties are bad. It's because you can mess up the state of the supertypes in ways that are not intended or not dealt with properly by all of your consumers. And it makes for very hard to track bugs. Okay, so when in general is S a subtype of T? So generally, S is a subtype of T if S intersects T with a new type. So do we have like some crayons here? No, we don't. Oh, sad. But like, I guess, like, imagine a circle here. If I say, well, I want this, but more specific, then obviously that's within the other one. Or S removes a subtype of T, like Ti from a union list. It's like, well, I either want like something which is countable and traversable, or I want something to be an array. Well, I can just be, oh, I just want arrays, actually, in this specific case. That's also feels visually a subtype. So a few examples. I have a list of union types. I remove a bunch of them. That's a subtype. I have an intersection type. I add more intersections. I make it more specific. That's also a subtype. I have an interface, like A. Like I have this whole world A. But I just want 2 elements, X and Y, which live within A. That's also a subtype. Same thing, but like I live in the world of A and B, and I want 2 elements which live in A and B. Those are also subtypes. Similarly, like I have things which are A and B, or I have this other thing D. If you want, you can think of countable and traversable or an array. Well, then if I have 2 specific classes that implement countable and traversable or an array, well, that is also a subtype. And finally, I mean, this one feels like the more obvious in that, like, well, you have either A and B. Well, X is a subtype of A, so obviously X is a subtype of A, and then I specify it and make it more restrict with C. So that is also a subtype. Mass alert. We're going to see a bit of mass. Hope I don't traumatize you. This is formally what it is. So when we're talking that U is a union type, and the union type can contain only one single element. So if we want to check that our union type is a subtype of another union type, we need to check that every single element of our union is at least a subtype of one of the elements of the other union. And if V is an intersection type, well, then we need to check that every single element of our union type is a subtype of every single intersection. The main difference between these two is what we call the quantifiers. So we have like the there exists, which means that, oh, we need only a single one. And we have the for all, that we need every single type to be validated for intersection types. So basically what it means is like we iterate over the UIs, and we verify that UI is a subtype of V. Which roughly, in PHP, this is what the C code does. Where, yeah, like we have a list of types, the second one, and then we do check like, oh, is it an intersection? If yes, it is, then we can exit quite early. Otherwise, we need to continue and iterate through all of the loops. So when is U, if it's an intersection, when is it a subtype of V? So this looks extremely similar to the previous slide. The basic difference is that the order of quantifiers is flipped. So we need to check V instead of U first. So we need to check the supertype first is constrained on. So we basically need to iterate on V first, like on the supertype. And then the other thing is that like we have also the quantifiers, which are changed from one point to the other. Checking that an intersection type is a subtype of another intersection type is, checking that an intersection type is a subtype of a union type is actually quite easy, is that we only need a single pair of a UI that is a subtype of one of the VJs to be true. But if V is an intersection type, then we need that every single, that for at least one of the UIs, like one of the subtypes, like it implements every single V1, and that like every V has at least one corresponding UI, so that like you don't miss part of the intersection. So you don't decide like, oh, I have something that is outside of my narrow scope. If you survive this far, you're probably fine. This is the hardest bit of the talk, I promise. So this is vaguely how it looks, again, like PHP, like related. Please ignore the like curly brace at the end of line 11. It's like it didn't fit in the slide otherwise. But yeah. But there's an interesting paper that came about, I think, like 3 or 4 years ago, which is all of this math and like rules and signatures and ways to like not mess up the state, and it gets very complicated to understand and remember. And so Elisa Banyard and Alexander J. Summers basically reframed LSP in terms of testing. Is that if you have a black box test of one of your classes, i.e. one of your types, which means that you don't actually test the specifics of like the implementation of each of your methods. Just you be that like, well, I have this spec, and if like these tests like validate this spec, any subtype, well, anything is a subtype and follows LSP if it actually fits and like respects these black box tests. Because it means that you don't actually alter any any state in a ways that are unexpected. So yeah. So what's the future of PHP's type system? A few different things that could be. I mean, user-defined type aliases might be nice. These are just 2 ideas of syntaxes that I came up. That, yeah, I want something numeric, which is like, well, I either have an int or float, and which happens quite a bit. Like, oh, I know that I can just use like arithmetic operations on it. Singleton types, if you use PHP Stan or Psalm or any other static analysis tools, you will usually encounter singleton types for array shapes or like specific like a union, or like in a way where like you had an integer act like as an enumeration, was like constants, like in PHP, like well known, like we have this, that like, oh, one parameter is just like a list of constants, and if you use something else, then who knows what happens. Function types, which would actually make callable enclosure give you some information that like what parameters it takes, how many it takes, and what is the value it returns. So again, syntax I came up, who knows if this will ever happen? Where you say, yeah, like this function would be like, well, my first parameter is an integer, my second parameter is a string, and I return a Boolean. Like, generics, anybody that seems to be very much into like static analysis and types will have probably used generics in PHP Stan, which basically tell you that like, oh, you have a collection which has of type T's, and then you can just, instead of needing to be like, oh, I have a collection of animals, and then I have subtypes which are a collection of dogs and collections of cats, you can just have like your one single implementation, and then you can like specify which type you want for your specific instance to be valid. The problem with this is that generics are kind of hard to make fast at runtime, which is what PHP does, and when the type checking happens, with a good developer experience. Like, except if you want to be always being like new, collection, T, sing, and like every single function, like that, it will get very cumbersome quite quickly. Arnaud Leblanc, who's also funded by the PHP Foundation, did like a lot of research last year about generics and what needs to be done and how we could get there, and like type inference and this sort of stuff, which is a blog post I think available on the Foundation website. However, about like 3-4 weeks ago, I started toying with this idea, mainly because on the mailing list where we make decisions, somebody was suggesting allowing never as a parameter type, which doesn't really make sense in telling you that like, oh, you can never call this method. The main way was to get basically the collection kind of thing, but so that you could like specify your own subclass, or implementation, concrete implementation of an interface, which has these things. So basically, we get this kind of the same way in what I call associate types, where you define, oh, my interface has like these types within itself, and the signature says that like, oh, well, you can say whatever offset you want. Now here I constrain it to like, it must be either a string or an integer, and you return any sort of value, and then any concrete implementation will say, well, here, my implementation says that like the offsets must be strings, and that the values are users. So I have a list of users, for example, or like I have a store, like a database storage of users. Don't know if I'll get this in 8.5. There's still like a bunch of stuff that needs done, but yeah, that's something I've been working over the last few weeks. Another thing is like would be in-out parameters. So normal PHP references are a bit terrible in various ways, like engine-related, but specifically for types is that they don't actually enforce a type constraint. They only check the type at function entry. So it means that like it will check that you are passing an array to the function foo, but it doesn't guarantee you that foo doesn't like alter the state or the type of the variable. So you can just change your reference of an array to an integer, and nothing will happen. So if you expect this to continue being an array, then bad things happen. And the thing is that an in-out parameter would basically prevent this, is it would like enforce the type constraint during the function. Effect types. This is now I find this very cool. I've learned this last year at like another conference, summer school type thing, which is instead of just having what type your function returns, it also tells you what effects it has. So for example, print would have like the effect of outputting something to your screen. fopen has the effect that it like does some I/O, but also that it might emit a warning if the file couldn't be found or you can't open it for various reasons. And for example, you could have like, well, the division is like, well, it either gives you a float or it throws a division by 0 exception. And then you can also, and like effects can be very vague and vast. You could have like, well, datetime immutable, like now, like, well, it returns me a date, but it also invokes the time because like time is always moving. And the way that normally ties in like other like functional programming languages is that you have a what we call an effect handler, where you can say for this scope, I want this effect to behave this specific way. So this would in some way enable mocking quite easily, because you could just be, well, IO in this test or in this code pass behaves this way. Or here, like the function now, like time, the time effect is always like the 1st of January 2000. So yeah, PHP strict types. Small audience question. I just want you to raise your hands up and down. Who has heard about strict types? Yeah, quite a few people. Who knows what strict types does? A bit less, okay. So PHP has 6 proper type juggling contexts, and then like now 3. It used to have 4 kind of weird ones, like special, they interact. So the string type juggling context is that, like, well, it's used for like echo, print, string interpolation, the concatenation operator, and it basically means that it will cast stuff to a string. So you know, true gets cast to string 1, and it gets concatenated with hello. Arrays are great in PHP, as you can just cast them to strings, and you get a nice wording, and you get like the nice string array with a capital A, very important capital A, in front of it. Now, PHP is sometimes sensible, is that like if you just try to like get a string of any random class, it actually throws you a type error. So thanks PHP, being nice. In PHP 9, it should be that the array case would also start emitting a type error. So you know, less weirdness happening. The integral and string type juggling context is specific to bitwise operators, which you might use if you use like constants to like flags, like bit flags. PHP allows to do bitwise operations on strings. So it does it like on a byte-by-byte comparison. And this only works if both of them are strings. If one of you have a numeric string, because PHP has this concept of numeric strings, with a string, then it will cast the string to an integer, and then it will do the bitwise operation that way. Surprisingly, so GMP is a class from an internal extension, which allows arbitrary mass, like integer mass, so you can have very, very big integers, which don't fit in a 64-bit machine. And this actually overloads the operators. So it overloads the bitwise operator, so you can do 36 bitwise a GMP object, and you get a new GMP object. The numeric type juggling context, this is where arithmetic operators just live. And yeah, so again, like cast everything to integers. The second example, like the line 2, might seem very weird to you. It's like, what do you mean? Like, I get like 1,000 here. Like, what does 1E3 mean? Yeah, numeric strings are allowed to be in exponential notation. So 1E3 means like 1 to the power of 10 to the 3, which is 1,000. So yeah, add them together, you get 1,123. And same as before, GMP overloads the operators. The logical type juggling context is when using conditionals, or like an if statement and things like this. There was like this weird case prior to 8.4 where like the GMP object actually didn't support casting to Booleans, and so it would actually like emit the only remaining case of like recoverable fatal errors, which are very weird that you would not expect that doing an if statement would break, but there's a way to do that in PHP. Comparisons are a massive mess. This is only the first bit of the table. This exists on the PHP documentation, and it explains how different like operands of like the comparison operator, like how they behave and what they do. And now if you look at the first thing and like in which order they try to check it and it happens. So if you have a string or null, it would actually like, well, converts null to the empty string and then does like a numerical or lexical comparison. If you have Boolean with everything else, then it's like, well, convert both sides to a bool, and then false is less than true. Objects, again, built-in classes can overload the comparisons. So for example, you can actually compare two date times. You can say, like, if you have two instances of date time, you can do if one is less than the other, and it will tell you that one is before the other. Here's your knowledge for today. And yeah, then like you have like a bunch of other rules, and like the next rules, more rules of like arrays. It's like, well, the array with less elements is considered smaller. Otherwise, it does like a key value comparison, but if a key doesn't exist, then it's considered uncomparable by PHP semantics, and then objects and arrays with everything else is considered greater. So here's a few implications from the previous rules. So like, yeah, an empty array with true is, well, the empty array gets cast to false, so op1 is less than op2. Two numeric strings get compared numerically, so the string 1 is equal to the string 01 for very reasonable reasons. Similarly, like exponential notation with OE5 and OE9 is that like 0 to the power of whatever is the same to 0 to the power of whatever. And then you can do string comparisons. So hello world, the reason why hello is less than world is that H comes before W. So obviously hello world is before, hello is before world. The way PHP encodes incomparability in the engine is a bit strange, in that it basically tells you that like the first operand is like always the greatest. So regardless of how you do the operation, you get the same result. Function types. So in this context, it's when you pass a value to a type parameter property or return from a function. Simply, it should be in this context, the value must be the value of the type. Except PHP has exceptions everywhere. Int is allowed to be promoted to a float. If the type and the value are scalars, the value is coerced to the type if it's compatible. And string types accepts objects that are castable to string. Big warning that the internal functions actually also coerce null to the scalar type. So if you pass null to strlen, it would coerce null to the empty string, and then it will tell you that, like, well, it has a length of 0. This is deprecated since 8.1 to align the behavior of internal functions with userland. So int to float promotion is quite simple. I have a function which takes a float. I pass it an integer. It silently gets promoted to a float. Scalar type coercion is if I have multiple types. So if I have a union type and I pass, for example, a string, it will first see if it can be coerced into an integer, and then it will check if it can be coerced to a float. And various ways it will do it like that. Which leads to this weird thing that like float is currently coerced to an integer with precision loss. So we truncate the fraction. But in PHP 9, when this behavior becomes an error, like the float would be coerced to a string. And strings actually don't really follow the rule of the order. They are coerced according to the numeric string semantics. So if the string is an integer, it gets coerced to an integer. If the string is a float, it gets coerced to a float. So here's like the last special type juggling things. Array offsets. If you try to use an array or an object as an offset, you get an error. Null is cast to an empty string. Resource bool and floats are cast to integers. Integer strings, which are the strings which only contain an integer, so they don't contain leading stuff, so they're not what we call numeric in other contexts, will be cast to an integer. So for example, the string 7 will get converted to the key, the integer 7 for the key, but the string 007 just stays that way. String offsets, like anything which is not an integer, either like emits an E warning or throws an error. So string offsets are actually way stricter than array offsets. Exit prior to 8.4 was its own language construct. So it didn't follow any of the usual function type juggling semantics in that if you had an integer, it would use it as a status code. Otherwise, it would just cast everything to a string. Since then, since 8.4, it actually behaves just as a function because it is just a function now. So if you ever had like a CLI script where you had like an has error Boolean variable and you tried to pass it to exit before it would cast it to an empty string, if it was false instead of the status code 0, it has lost me about like 3 hours of my life trying to debug CI while my CI pipeline was failing when I was getting no output, which was a very fun time. And then we have increment and decrement operators, which are just a massive mess. So let's go through them. So a few types of behaviors if you just did like +1 and -1. So integers, floats, and internal objects that overload plus minus. OK, very simple. You get type errors for array, resources, and objects. Cool, very nice. Works wonderful. Null, like from 8.2 and below, is that like, well, if you try to decrement null, you get null. And if you try to increment it, you get 1. Which, sure, why not? Which does not behave the same way as like addition. Like if you try to do -1 on null, you get -1, like because it just gets cast to a 0. Since 8.3, you get a warning that this is going to change. So we are trying to align the behavior of the decrement and increment operators to be just +/-1. So it's like actually simple to just reason about everything. So yeah, false. So you try to decrement it or increment it, it does absolutely nothing. Like it doesn't get cast to an integer, it just stays false. And similar, this is now a warning that this has no effect and this will change in a future version of PHP, because again, we're trying to align the behavior of +- to be the same as like just the normal arithmetic operators. I'll go quickly through this. True behaves the same way, it does nothing, and it now emits some warnings. Strings, the empty string, like if you do minus on it, that actually casts it to an integer and you have -1. But if you increment the empty string, you get the string 1, which is a number, but it's not a number. So since now you get some warnings that, like, because empty string is not numeric, and it has never been. Now what you may see is that like the deprecation message is a bit different. Like decrement on empty is deprecated because non-numeric. Increment on non-alphanumeric string is deprecated. Because yeah, PHP has this wonderful feature that it took from Perl, which is string increments. So you can have you can increment like a string, and it will do Excel-style column, but like incrementation. So when you get to Z and you do ++, well, you get AA. This also like does lowercase, uppercase. So if you have lowercase Z, it does lowercase AA. But if you have mixed case, you get some very weird results. But this feature is it's a bit buggy. If you have a trailing space, it doesn't do anything because it sees that the last character is a space, and it's just like, well, clearly this is not an alphanumeric string, so let me not do anything. And if you have a leading space, then I guess you can do mod 26 arithmetic, just integrate it into the language, because it just loses the carry for some bizarre reason. So both of these things are deprecated in 8.3. The full deprecation for string increments is not yet there, but in 8.3 we also added str increment and str decrement, so that you could do this Excel-like string incrementation if you needed to, before we can actually get rid of this whole behavior. So what could possibly go wrong with doing string incrementation? Like obviously, if I just have a string and I like increment it 100 times, I get a string. Oh, I don't. What? So the reason is, at one point during this iteration, you get to the string 5D9, which when you increment it, you get a 5E0, which is a string in exponential notation. So PHP looks at it, and it's like, oh, I know what this is. This is a floating point number. Let me cast it to a float, and then add 1 to it. So yeah, that's it. So when does actually strict type have any effect on your code and your code base? You could think it would affect a few, but it only affects one. It only ever affects the function type juggling context. So what this means is that, well, so it's only enabled if you have like the declare or the strict type things, which if you follow PSR 12, I think is the new version, or PSR what, like I don't know which one like initially did it. It's like they tell you to use strict types everywhere. But the only thing it does is that it disables the coercion of scalar types in the following case only. If like the arguments are passed to our function calls, which are made in userland, is a return value for user-defined functions and assignments to a type property. So it does not change how binary operations works. So arithmetic operations will still cast stuff to integers, and like concatenation will still cast stuff to string. It does not affect the comparison operators. So the weird thing where you have like 1 is equal to 0, 0, 1, and like stuff, this still works without any issues. And you can have like the comparisons between like arrays and truths and things which doesn't really make much sense. That still works. And I think most importantly is that it doesn't change the behavior of functions which are called by the engine. So even if you define your own function in a PHP file, which has strict types enabled, when the engine calls this function, for example, here was array filter, to check that every single, like to filter the elements of your array, it will revert back to weak mode. It will do the type coercions. And I think for this primary reason, we have a bit of a hot take, is that the strict type declare was a bit of a mistake. In this weird sense is that strict types was this very, very effective band-aid around type juggling and semantics and be like, oh, we can just brush this over the rug, and like people who want to have all of the type juggling that can deal with it, and everybody else can have like the strict behavior. But that's not really true. So yeah, that was my talk. Thank you for listening to me. I don't know if we've got time for questions. So a few minutes, apparently. So if anybody has a question, you can either ask it now, or you can come see me after the talk, or at any point during the day. I'm happy to chat. So.
Yeah, first of all, thanks for the talk. It was very insightful. I have 3 questions. First question, I'm using strict types in all my PHP files.
Yep.
And I thought all the time it's good practice.
Yep.
So was it just wrong? Should I remove it from every
No.
PHP file?
No, you probably should still keep it.
So I should keep it, right?
Yes.
Okay, good. Then I will keep it. So it looks like it's better than not having it.
Yes.
The second question is, we have this smaller than sign, question mark, PHP in the first line of every PHP file.
Yes.
In other programming languages, we don't have it. I understand why we have it, because in the former times of PHP, yep, we could integrate PHP in HTML. But nowadays, we don't use it. And can this be removed from PHP so we save lifetime?
I feel like you get into this thing where you would need maybe a different like file extension, or you would need to say, well, if you get like, I don't know, like a PHP S file, like PHP source file, then just interpret everything as PHP. I think it's just that like a lot of people, it's just that like, that doesn't seem like that big of a deal. So I don't think a lot of people have invested time in it. especially because it'd be like, well, you can't just decide that every file that you include or require is now going to just be pure PHP code. So there would need to be a different mechanism to maybe I guess we could do what every other programming language does and add an import statement and be like, well, if you have import, then it is a PHP file, and then maybe only your main in index.php needs to have still to be oh, I'm getting into PHP mode, and now from then just start importing. That might be a solution. Yeah.
Okay, so you meant it can be possibly integrated into PHP?
Yeah, we could possibly do it.
Do you plan to integrate it?
I have way more other stuff that I find more pressing that I'm working on, but I mean, there are a few people, maybe you could get somebody else to do it, but that's not on my own personal roadmap.
And last small question, I like the presentation tool. Which presentation tool was it? Because it shown the slides.
Okay, so I wrote this in tips. So this is a PDF. So tips is, if anybody has done LaTeX back at university, it's LaTeX, but 20 times better, and it's Markdown.
Tips, okay.
Yeah, and so a few things, I have a few packages, so Codly and stuff, but I'm happy to show you how it looks after.
Okay, thank you.
I don't know if there's more questions or if it's time over, but...
we'll have to stop.
Okay, so apparently we need to stop. Come see me at the end of the thing, or just now. But yeah, thank you, and...